You know I'm statistic. You know it. It's true. Ow! So, this is going to be the same type of hypothesis test as the last video, but it's such a cool story, I really want to share it. This was back when I was teaching in Texas, true story. The final exam was 50 questions, multiple choice questions. And at the very back was a student who was taking his exam like this. And I said to him, keep your eye on your paper. He does it again, and so I made an announcement. I see some eyes wandering. I'd like to remind people to keep an eye on their own exam. Okay, so it's disruptive for me to pull a student out in the middle of the exam. So after the exam, we made an appointment to talk, but beforehand, I looked at his exam, and here's what I discovered. If I took this student's exam and randomly compared him with other students in the class, he matched about 67% of other students' random questions. In other words, his exam should match 67% of any one student's, not whether he got the questions right or wrong, how many of his questions matched, because there's some questions almost everybody got wrong and some questions everybody got right. Now, sometimes he matched less just by luck, and sometimes he matched more just by luck. For example, I looked at 2 random students that he was not sitting by at all and found with Adam, he matched 30 out of the 50 questions. On this curve, that lands right about there for Adam. Another random person he wasn't sitting by, Liz, matched 39 out of the 50, and that landed right about here. Okay, so this was the curve of what it looked like for all students, which I know he didn't cheat off all students, it was the student to his right. How many did he match with the student to his right? Well, it looked like this. Now, 42 out of 50 looks like a lot, but 39 out of 50 was a lot, and yet it was still in a reasonable spot on the curve, not that we can prove there was any cheating. So let's try a full hypothesis test, the null and alternative. We're going to have the null be the proportion is 0.676 or less, or something close to it. Anywhere in this range, we'll say the null is true, and this is where we're going to say it doesn't look like there's evidence of cheating. But here, the proportion is more than 0.676. It's more than just luck. It's significantly more, which suggests there was cheating. This is a case where we will want to change our alpha. 0.05 is typical, but accusing a student of cheating is a very big deal. So I'm going to lower my alpha. I'm going to push the edge out of where you have to be. Let's make it 1%. Now, I was about to show you the z-score, but I realized before you can do a z-score, you have to ask yourself, is there enough data? Is 50 questions enough to be able to do a hypothesis test on whether someone cheated? Well, we're going to take p times n, so 0.676 times 50, that gives us 33, way more than the 15 we need. But 1 minus 0.676, that's a smaller proportion, times the 50 gives us 16.2. So yes, that's enough. Now we can do the z-score. The z-score is going to be p hat minus p over our standard error, which is the square root of p1 minus p over n. That gives us a z-score of 2.48. On the picture, he lands 1, 2.5. This is where his neighbor was landing on that graph. Is that far enough out there that we have evidence of cheating? I'm going to put 2.48 for my curve, and I want the probability of getting a proportion that high or higher, because this is the area where we say something weird is going on. You matched too many questions with your neighbor. Look at that p-value. Even with an alpha of 0.01, this p-value is still too low. Another way to describe this p-value is if you weren't cheating, the chance that you would match his test this closely is about a 0.5% chance. So I pulled the student into my office, I showed him this curve and the hypothesis test, small p-value, and I said, look, there is a 99.4% chance you cheated. That's totally an abuse of it. He either cheated or he didn't. The probability is 0 or 1. But if he understood that, then he wouldn't have needed to cheat on the exam in the first place. And he looked at this and said, well, I looked at my neighbor's formula sheet to just make sure that I had the right formula sheet on my paper. Okay, we call that cheating. Conclusion, don't try to cheat in a stat class, okay? We do look for things like that, and clearly this was enough to show something unusual was going on. What was it? Well, I happen to know because I was watching the student that there was cheating that happened.